Okay, look, I hope you've had a chance to really look at the algorithm and understand how we really are moving from really state to state. Now, what I'm trying to do now is basically come up with what we call a truth table. It's really more specifically called a state table, but it really is nothing more than a truth table. Let's see how we actually do this. Okay, on this side over here we have inputs, and so I have AB. Now, AB really represents, if you like, what we might call the present state. Okay, that's the present state you're in. This is, of course, the switch input that the pedestrian would press. AN and BN, of course, is the next state you will go to when you get the clock edge. You haven't gone there until you get the clock edge, okay? And then these are our light conditions over here. Once again, as I said to you, I'm going to really be assuming a high acting situation, okay, as far as these lights are concerned. All right. So let's do this. Let's imagine now we're in the 0, 0 state. So we'll write this down. I am in the 0, 0 state. Does it matter what the switch is? Well, yes, it does. If the switch is what? 0, okay, 0, then the next state I would move to when I get the leading edge of the clock would be back to the same state, which would be the 0, 0 state. Okay, what lights do I want on? Well, look at the state you're in. You're in the present state, the 0, 0 state. So whatever you see in the rectangular box are the outputs that you want active, the outputs you want on. We've got the green light on, we've got the white light on. Okay, so this is on, the other lights are off, apart from the white light, which should be on, and the go light is off. Okay? All right, if I'm in the 0, 0 state, but this time the switch is pressed, it's a 1, okay? Where would I go next when I get the next leading edge of the clock? Yes, I'd go to the 0, 1 state. So that's our next state, the 0, 1 state. All right, what lights do I want on here? Now, people often make a mistake at this point. Often people come along and they say, yeah, I want the yellow light on. And I'm going to say, no, you don't want the yellow light on. Why? Because I look at this, it says 0, 1, you want the yellow light on. No. This is where you go next. You're not there. You will go there next when you get the leading edge of the clock. Where are you now? You're in the present state right here. These are the inputs, 0, 0. You're in this state here right now, 0, 0. So whatever you see in the box for 0, 0, those are the lights you want on. So what do you see in the box? The green light and the white light. So the green light is on, this is off, this is off. White light is on, off. All right, that's the 0, 0 state, finished. Let's now look at the 0, 1 state. If I'm in the 0, 1 state, there you are, do I care about the switch? No. The switch has no bearing on where I will go next. So I'll represent that by a little x. Don't care, all right, what the switch condition is. Okay, if I'm in the 0, 1 state, where would I go next when I get the leading edge of the clock? Well, I'd go to the 1, 0 state. So I'll write that down. That's my next state I will go to when I get the leading edge of the clock. All right, what lights do you want on? Well, again, that's where that mistake can occur. You're not in this state, you're in this state. This is inputs. The present state you're in is the 0, 1 state, so whatever is in the rectangular box here for the 0, 1 state, those are the lights that you want on. What is it? North, south, yellow, and white. Okay, so you want the yellow light on, and you want the white light on, the other lights are off. That deals with that state. Okay? All right. If I am in, let's say, the 1, 0 state now, that's this state. Do I care about the switch? Can you see any switch associated with that state? Nope, don't care. What's the next state I would go to? If I'm in this state, where would I go when I get the next leading edge of clock? I would move to the 1, 1 state. That's the next state we would go to when we get the clock. What lights do I want on? What state are you in? You're not in that state, you're in this one. You're in the 1, 0 state. That's where you currently are, that's the present state. All right, what's in the square box for the 1, 0 state? There's the box. What's in it? 1, 0 state, north, south, red, and white. Okay, so I basically want the red light on, and I want the white light on, like so. That deals with that particular state. Okay, if I'm in the 1, 1 state, I'm in this state now, the 1, 1 state. Do I care about that switch? Doesn't affect where I go next? Don't care. If I'm in the 1-1 state, when the next clock cage comes along, where would I move to? Go back to the beginning, the 0-0 state. What lights do I want on here? Well, what state are you in? Yes, you're in the 1-1 state. That's where you are right now. That is the present state. So whatever you see in the square box for the 1-1 state, those are the lights you want on. North, south, red, and go. So basically I want this off, I want the red light on, white off, letting the people cross the road. Okay? And that is it. We have covered all 4 states. So really what I have then, basically S is an input, A is an input, B is an input, that's my present state, that's my switch, that's my next state, my lights. My state table has done what? It's described the relationship between these outputs and these inputs. And so really now I should be in a position to design the logic that goes in here, okay? Because I've got the input-output relationships, okay? That has come from where? That has come from that state table, okay? So we should be able to take that state table and work out the Boolean equations for the outputs and then implement the logic. So what is it I need to do? Well, look, these are the inputs, 3 inputs, and these are all the outputs, okay? So I need to what? Take one output at a time. So I could take AN, come down the column for AN, identify the product term. Here's our first one. What do you read off as a product term? Do you care about S? Nope. So what do you read off? A bar, B. All right, come down the column. Next product term. What's this product term? A, B bar. All right, and that then deals with AN. Let's just write that down very quickly right here, okay? And then we'll continue this, all right? So AN would be equal to what? Coming down the column, look across at the inputs that produce that product term. It's A bar, B. So let's write that down. A bar, B. Or, come down the column again, next product term, we have A, B bar. So that's A, B bar. Do you recognize what gate that might be? Yes, it's an exclusive OR gate. So already we've got the gate, as it were, for AN. All right? Okay. What about Bn? Well, look down the column for Bn. All right, here we go down the column. Here's my first term, isn't it? My first product term. What combinations of inputs do I need to implement that term? Well, I need S, A bar, B bar. So let's write that down. Bn then is really what? It's S, A bar, B bar, or coming down, I've got another product term here, haven't I? What is this product term? This would be A, B bar, wouldn't it? So this is really A, B bar. Okay, is that it? A, B bar. Don't care about S in that case. I've got Bn. Now, can we simplify Bn? Well, let's have a little look at that. All right, let's see if we can actually simplify this. Look, you can use Boolean algebra. We might better use just a K-map. Let's just draw a K-map sitting here and see if we can actually simplify this expression. Okay, so my variables are S, A, B, 0, 0, 0, 1, 1, 1, 1, 0, 0, and 1. All right, let's do this. Okay, S, A bar, B bar would be a product term sitting here. Okay, what about A, B bar? All right, that's A, B bar, isn't it? So I've got a 1 sitting here and a 1 sitting here. Okay, does this minimize? Well, yeah, look, that's what we had before. I've got to grab those two. So Bn is what? It is just simply A, B bar. Yeah, okay, can't do much about that. But look, I can grab this term with this term right here. Or, what's common? S, yes. What's common here? B bar. Okay, so yes, there is some simplification right there. All right, let's continue. North-south green. All right, so we'll write down our Boolean equation for north-south green. All right, let's see what that is. Come down the column. Oh, look, there's my first product term. What is that? Well, that's what? S bar, A bar, B bar. All right, so I could write that down. I'll write it down. S bar, A bar, B bar. Or, come down again. Oh, look, this is what? S, A bar, B bar. So this is really S, A bar, B bar. Now, can that be simplified? Well, yeah, look, do I need to do a K-map or is it obvious? Well, in a sense that you could say that this is fairly obvious, because you could say that, look, north-south green only ever occurs if you're in the 0-0 state. Okay, it never occurs anywhere else. Okay, so you could say that north-south green surely is A bar, B bar. But look, if you wrote each one of these terms down, okay, it doesn't matter, because look, basically what could you do here? You could factor out A bar, B bar. And so really I've got A bar, B bar into what? S bar or S. What is S bar or S? It's just one, isn't it? And so this is really A bar, B bar for north, south, green. Okay? Fairly straightforward. All right? Okay, let's do north, south, yellow. All right? North, south, yellow. North, south, yellow is what? Oh, well, this is a relatively easy one. There's only one product term there, isn't there? Which is what? There it is. It's A bar B. A bar B. North, south, yellow. Okay, what about north, south, red? Here it is. Come down the column. First product term, what do you read off? So let's write that down. North, south, red is what? A, B bar. So A, B bar. Come down again. Oh, look, what have you got here? A, B, or A, B. Okay? Can you simplify this guy? Well, you should be able to, shouldn't you? Factor out the A, what are you left with? B bar or B, and what's that? That's 1. So north, south, red is really just what? It's really just A, isn't it? Okay, that's an easy one. Okay, let's have a look at weight. Now what I thought I'd do is I put a little 3-variable K-map down there. You can have a look at plotting directly on the K-map. All right, let's do that. Okay, here is weight. First product term is there, isn't it? 0, 0, 0. S bar, A bar, B bar. So I've got a product term sitting there. Next product term is 1, 0, 0. Sitting here. What's this product term here? Basically it's what? A bar B, isn't it? So wherever A bar B is true. Where is A bar B? Well, A bar B is right here. A bar B, wouldn't that be A bar B? There and sitting there. Okay, that's that product term. What is this product term? A B bar. Oh, that's a product term sitting there and there. Have I got all the product terms? A, B bar, I believe I have. And so now perhaps we could see about minimizing this K-map here. Okay, minimization here. Well, look, certainly I can grab those together. And so I can basically write that weight is what? It is, looking at that, what is common here? The only thing that really is common here is A bar, isn't it? And then I could group what? These with these two here. And what is common in this case would be what? Just B bar. Now I want you to verify that for yourself. Make sure you're in agreement with that. Okay? And so a quick minimization there. Okay. Now one other thing you might have noticed here, and maybe your tutor can talk to you about this, is that look, you could have, look, there's only a 0 here. You could have minimized the 0 and invert, but don't worry about that for now. Let's do go as the final one. Well, go is pretty easy. Only one product term, which is what? Occurs when the inputs are A, B. All right? And that is the go case. All right, what I want to do now is take a break. I want you to go back over this material. I want you to basically redevelop those Boolean equations. And why don't you think about actually drawing the logic from the Boolean equations, okay? And then we'll come back when you're ready and pick that up.